Alright kiddos, we're going to talk about percent composition. This goes right along with what we've been talking about with moles. This is not a terribly difficult thing, but it's definitely something that you need to pay close attention to and make sure that you know the steps really well. Okay, so the way this works is that what percent composition is basically what percent of the total compound is each element. So if we look at an example like this one where we've got ethane, where we've got C2H6, we're talking about calculating how much of that formula is carbon and how much of it is hydrogen. This is often called mass percent because what we're really worried about is what the mass is. Okay, so step one for solving one of these is to find the molar mass. That's what we've been doing lately anyway. Okay, so we split it up, 2 carbons, carbon is 12, 6 hydrogens, hydrogen is 1. Okay, so we're going to multiply those out. 2 times 12 is going to give us 24. 6 times 1 is going to give us 6. Okay? And then we're going to total it up. And that's going to give us our molar mass. And that would normally be, if we were doing conversion factors, what we would use as our conversion factor. 30.0 grams per mole. We'd say 30.0 grams equals 1 mole. For percent composition, though, what we're going to do is we're going to then take these numbers, okay, the total mass of the carbon, the total mass of the hydrogen, and we're going to divide them by the total. Okay, so I'm going to take the 24 grams of carbon, okay, over here, and I'm going to divide it by 30, okay, which is the mass of the whole thing. So the part that I'm worried about, the carbon, divided by the total, 30. Punch it in your calculator, you're going to get 0.8, okay, 0.8. We like to keep at least 3 or 4 decimal places there, so 0.800, because we're going to multiply that by 100 to get the percent. Okay, so that's going to give us 80%, and really that I probably should have written that as 80.0%. We always kind of try to keep at least 1 decimal place there, but since it turned out so even, I left it off. Okay, so that's how we do the first part. Now, if we're doing the whole percent composition, like when the problem just says calculate the percent composition, I'm going to do the same thing with hydrogen. Okay, so I did carbon up here. I'm going to do hydrogen down here. So I take the total of hydrogen, the 6 grams that's here, bring it down here, divide it by the total, and then that's going to give me 0.200 in this case. Multiply that by 100, it's going to give me 20%. So 80% is carbon, 20% is hydrogen. If I add those two things together, they should add up to 100, or pretty close. There might be some rounding errors. You might end up with like 99.9 or 100.1 or something like that, but it should be pretty close when you do that. Okay? So that's, I mean, it's really not that complicated, but that's how that's going to work. We can also have the problems worded in a different way. So if you look at this one, it says calculate the percent nitrogen in NH3. Now in this case, what they're looking for is I don't have to do the percent of everything, but I do need to find it just for nitrogen. The thing is, to find the total, I still have to work the whole molar mass. Okay, so I've still got my 1 nitrogen. Okay, 1 times 14, going to give me 14. I've got 3 hydrogens, so 3 times 1 is 3. I add those up and I get 17. Okay, again, if that was conversion factor, it would be 17 grams equals 1 mole, but we're just going to take it as grams per mole. So what we need to do here, since I'm just looking for nitrogen, I'm going to take just the nitrogen part and I'm going to divide it by the total, just like we did the last time. So 14 divided by 17. Okay, we punch that into the calculator and we're going to get 0.81 repeating. Okay, 81, 81, 81, 81, all that, I believe. Yeah. Okay. I'm sorry. No, that's not right. Okay, we're going to get 0.824. Okay, forget what I said before. We multiply that by 100 to turn it into a percent. You always turn a decimal into a percent by multiplying it by 100. And that tells us that we got 82.4% nitrogen. Now you could easily calculate the hydrogen, or you could just subtract from 100, but we don't really need to. It just asks for nitrogen. If you look at this slide, we don't even have to have the formula to be able to find the percent. In this example, I've got 9.03 grams of magnesium, 3.48 grams of nitrogen, and they form a compound. Question asks us, what's the percent composition? Now, I don't have a formula, so I can't do molar mass, but I can find the total mass. I just take those two numbers, okay, and add them up. So 9.03 plus 3.48, okay. we're going to get 12.51. Okay, that's our total. And then to find the percent, we do the same thing we did in the previous problems. I take my 9.03, I'm going to divide it by 12.51. I take my 3.48, I'm going to divide it by 12.51, and then multiply by 100. Okay, that then is going to give me a percent. Remember that when I do this step, when I do the first division, I get a decimal, and to turn any decimal into a percent, I just have to multiply it by 100. So that's what we're going to do next. So 9.03 divided by 12.51, I get 0.722. 3.48 divided by 12.51, I'm going to get something 0.27 something, 8, okay? And then we're going to multiply those by 100, and that's going to give us our final percents. So I've got 72.2% is magnesium, okay, Mg. Got to label them, got to know which one's which. And 27.8% is nitrogen. Okay, pretty simple. If I added those up, I'd get 100%. If you do the whole thing, it adds up to 100. If you only do part like we did in the nitrogen one, it just is what it is. Okay, the other way that you're really likely to see this problem, and this is the one that usually throws students off, is if you see a problem like this. It says calculate the mass of carbon in 82 grams of propane. Okay, and I forgot to write the formula for propane here for you, but this is it. It's C3H8. We've used it in another problem. I just forgot to write it on this one, but it's C3H8. So we got 3 carbons, 8 hydrogens. Okay, so anytime I'm doing percent, okay, or the mass of something in something else, I got to do percent. So I'm going to do my molar mass like I normally do. So 3 times 12, okay, carbon's 12, got 3 of them, 36. 8 hydrogens, hydrogens are 1. I add those up and I get 44.0 grams per mole. Okay, so since I'm looking for carbon, just like I was nitrogen a couple slides ago, I'm going to take the 36 of carbon and divide it by 44.0. Now, here's what's different. Okay, I'm going to get an answer here. And normally we would take that decimal answer and we would multiply it by 100. I don't want to do that this time. Okay, so I'm just going to take my decimal answer, 0.818. Okay, I'm going to take that number, non-percent, okay, before I turn it into a percent, and you multiply it by the mass given. So I have 82 grams of propane. Okay, that's what the given is. And I'm going to multiply it by 0.818, and that's going to tell me how much of that 82 grams is carbon. Now, if we did this percent-wise, carbon would be 81.8%, almost 82%, so most of it's going to be carbon. So when I multiply this out, it should be definitely a number bigger than half, so it should definitely be a lot bigger than 41. And when we calculate it out, we get 67.1 grams of carbon. Okay? Now, this stuff is not hard, but this is definitely one of these things that is very step heavy. In other words, you need to follow the steps each time. So you probably want to go back and view this again, okay, when you get a chance, or maybe when you're working on the worksheets. I highly recommend that, because this is, again, very step-centric. If you just follow the steps, you'll be okay. But if you don't take the time to do the steps, then things tend to turn out a little bit worse. All right, guys, we're going to stop the moles unit here. Sometimes we go a little bit further, but the last couple of things I'm going to leave for later in the semester. So we're going to stop here. So if you haven't at this point, if you're watching this online, you should be able to get the whole DVD if you need it. And we're gonna stop here, and so we'll probably have a test next week or so sometime on this stuff. Thanks, guys.